Okay, now to show why the analysis method might be a bit more difficult, let's look at the graph of this. Okay, so minus 3 and then absolute value of 2x plus 1 minus 2. It might seem very tedious to do it this way and do the composite graph where I just say minus 3 times the positive part for this positive. Okay, so all I changed was this. I just put the positive part multiplied by -3 and then minus 2. Okay, for the thing inside being negative, that means I will have a graph where it's minus 3 times negative 2x plus 1, negative 2x plus 1, minus 2, for this being negative. I'll give examples like this with answers of writing this out. This is important to be able to go from here to here. As a composite function, just applying the absolute value rule or the definition of it. Okay, now all I did was multiply this out, solve this. I did it in like 2 steps. In the end, I get 2 lines. Y is equal to negative x minus 5 for x greater than a half, and 6x plus 1 for x smaller than negative a half. This is also negative a half. Okay, so if I go and analyze this using the previous method where we looked at, does it move to the right, does it move to the left, up or down? Okay, easy to see it moves 2 down from the starting point, so it doesn't start at 0, 0. It starts at least at -2 for y value. To determine where it starts from an x value and what its slope would be, to draw it using the more analysis-based method, I need to remember that alpha x is the same as absolute value alpha, absolute value x, like this. So that means negative absolute value 3 times absolute value 2x plus 1 would be the same as, keeping my minus, only taking in the positive number, negative absolute value 6x plus 3, keeping my minus 2 there. So I have a negative in front, which immediately means I know it's pointing downwards. But to know where it starts from, I need to determine was something plus or minus from my x. Be careful, this isn't 3 plus 2x, it's 3 plus 2, 6x. So I first need to solve and factorize again, so you can see it's more difficult. And I need to factorize that 6 out, or just, divide it out to show what has been added to my x. In this case, it's a half, like this. Let me just see that makes sense. Yes, a half minus 2. So now if I go and analyze, it starts 2 down from the origin, and plus a half means it moved a half left. So it starts from negative a half, 2, like this. Oh, sorry, negative 2, 2 down. So a half to the left, 2 down. This is the starting points of my graph. Okay, now you can see it's not that easy to come to that conclusion. But if I go and look at it and say this is -1, so negative a half, -1, -2, it would start from there. And what would my gradient be? It's 6 in front of the x, 6. So it means for every, and this is a negative shape, like this. So for every 1 to the right, I go 6 down. So I can go 1 to the right and go to a half here, and go to -8 over here, and say a half, -8. It's pointing down like that. It's obviously connected properly, not like I did. And just draw the symmetric side on the other side, and there's your graph. Now, you can see it's actually a lot of knowledge to be able to do this, if you're able to, 100%. If you're not, you anyway should be able to do this. So stick to this, draw these 2 graphs for bigger and for smaller than a half, and you'll see it looks the same. To draw these 2 graphs, again, I can analyze with gradients, like I drew that one, or I can do the table method. Anything you want. You should be able to draw a straight line since grade 9. And there are videos on drawing a straight line that I uploaded to YouTube and posted to Google Classroom as well. So go and look at this. I'll post more difficult ones like this, about 2 or 3 of them that I write into composite value functions. and that I can then post the graphs for, so you can check if you can use this info to draw the graph. If you're able to do this, remember you have to see what's added to x in isolation, not to 6x, to determine how much left or right it went. Use this 100%. It's not essential that you can.